share a fun fact. Welcome to Let Me Share a Fun Fact, where we dive deep into the wonders of the world around us. Today, we're about to unravel some of the most intriguing science and technology curiosities, from the tiny neurons firing in our brains to the majestic way honey is made by bees. Whether you're fascinated by the inner workings of electric motors or the ancient art of telling time with sundials, this journey is sure to spark your curiosity and leave you with a deeper appreciation for the everyday marvels that often go unnoticed. So, sit back, relax, and let's explore these amazing facts together. How contact lenses correct vision, a tiny miracle. Contact lenses are tiny marvels that sit directly on the cornea, yet their impact on vision is monumental. These small, curved pieces of plastic or silicone work by altering the way light enters your eye, ensuring that it focuses correctly on the retina at the back of your eye. This process corrects common vision problems such as myopia, nearsightedness, hyperopia, farsightedness, and astigmatism. In a normal eye, light enters and is precisely focused on the retina, allowing you to see clearly. However, if the shape of your eye is off, this focus can occur in front of or behind the retina, leading to blurry vision. By sitting directly on the cornea, contact lenses compensate for these imperfections, bending the light in a way that corrects the focal point. It's almost like having a lens crafted perfectly for your unique eye shape. The science behind it is complex, but the result is simple, clear, sharp vision that feels almost natural, as if the lens wasn't even there. This tiny piece of technology has revolutionized the way millions see the world every day. The magic of DNA markers, decoding life's blueprint. DNA markers, often referred to as primers, play a crucial role in the world of genetic research and diagnostics. These short sequences of nucleotides are like the bookmarks of the genetic world, guiding scientists to specific regions of DNA that need to be studied or amplified. The magic happens during a process known as polymerase chain reaction, PCR, where these primers bind to their complementary sequences on the DNA strand. Once attached, they enable the DNA polymerase enzyme to start copying that section of DNA, effectively amplifying it. This is essential for identifying genetic mutations, forensic analysis, or even understanding evolutionary relationships among species. Without primers, finding a specific sequence in the vast ocean of DNA would be like trying to find a needle in a haystack. But with them, scientists can zoom in on the precise part of the genetic code they're interested in, turning a single copy of DNA into millions, making it much easier to study and understand the mysteries of life encoded within our genes. Electric motors, the invisible force behind modern life. Electric motors are the unsung heroes powering much of the technology we rely on every day. From household appliances to industrial machinery and electric vehicles, these devices convert electrical energy into mechanical motion, enabling a wide range of applications. The magic of an electric motor lies in the interplay between magnetic fields and electric currents. When an electric current passes through a coil of wire within the motor, it creates a magnetic field. This magnetic field interacts with the field of a permanent magnet or another set of coils, creating a force that turns the motor's rotor. This motion can then be harnessed to do everything from spinning a fan blade to propelling a car. The beauty of electric motors is their simplicity, yet they are incredibly efficient and versatile. Unlike combustion engines, they produce no emissions and operate quietly, making them a cornerstone of modern efforts to reduce pollution and noise. As technology continues to advance, electric motors are likely to become even more integral to our lives, driving everything from the tiniest gadgets to the largest machines. The chemistry of fireworks, how explosions paint the sky. Fireworks are a dazzling display of chemistry in action, lighting up the night sky with a rainbow of colors. But have you ever wondered how these colors are created? The secret lies in the compounds used in the fireworks construction. Different metal salts and elements emit specific colors when heated to high temperatures during the explosion. For example, strontium compounds produce brilliant reds, copper compounds create vibrant blues, and sodium salts give off intense yellows. When a firework explodes, these compounds are heated to the point where their electrons get excited and jump to higher energy levels. As these electrons return to their normal state, they release energy in the form of light. The wavelength of this light determines the color we see. Firework designers carefully choose and combine these compounds to create the multicolored bursts that make fireworks so spectacular. The next time you watch a fireworks show, you'll know that it's not just a random explosion of light, it's a carefully orchestrated symphony of chemistry and physics working together to dazzle your senses. Autopilot systems, the science behind self-flying planes. Autopilot systems in airplanes are a testament to the incredible advancements in aviation technology, allowing aircraft to fly safely with minimal human intervention. These systems are complex networks of computers, sensors, and software designed to control the aircraft's flight path, altitude, and speed. Once the plane is airborne, the autopilot can take over, using data from various sensors, such as gyroscopes, accelerometers, and GPS, to continuously adjust the plane's controls. The system ensures that the plane follows a predetermined flight path, maintaining the correct altitude and heading, while also managing speed and engine power. Pilots can program the autopilot with waypoints and destination data, and the system will handle the rest, constantly making small adjustments to keep the plane on course. While it might seem like the plane is flying itself, the autopilot is actually responding to thousands of pieces of data every second, making micro-adjustments that keep the flight smooth and on track. This technology not only reduces the pilot's workload but also enhances safety by maintaining a level of precision and consistency that's difficult for a human to achieve over long periods. Mechanical wristwatches, timeless engineering in every tick. Mechanical wristwatches are more than just timekeeping devices, they are miniature marvels of engineering. Unlike their digital counterparts, which rely on batteries and electronics, mechanical watches operate through a complex system of gears, springs, and levers. At the heart of every mechanical watch is the mainspring, a tightly coiled spring that stores energy. When wound either manually or automatically through the movement of the wrist, the mainspring slowly uncoils, releasing energy in a controlled manner. This energy is transferred through a series of gears to the escapement mechanism, which regulates the release of energy, allowing the watch's hands to move at a steady pace. The escapement is what gives a mechanical watch its characteristic ticking sound, as it allows the gears to advance incrementally rather than continuously. Each tick represents a tiny burst of energy, precisely metered out to keep the watch running accurately. What makes mechanical watches so fascinating is that they do all of this without any electronic components. They are a testament to human ingenuity, representing centuries of refinement and craftsmanship. Even in a world dominated by digital technology, the mechanical wristwatch remains a symbol of timeless elegance and precision. Hey there! If you're enjoying these fascinating facts, don't forget to subscribe to let me share a fun fact. By subscribing, you'll never miss out on any of our deep dives into the world of science, technology, and everything in between. So go ahead, hit that subscribe button, and join our growing community of curious minds. The science behind menstrual pads, discreet yet powerful protection. Menstrual pads are a quiet but essential piece of technology in women's healthcare, providing comfort and protection during menstruation. The magic behind these pads lies in the materials they are made of. At the core of every pad is a superabsorbent polymer, SAP, a material capable of absorbing many times its weight in liquid. When fluid is absorbed, the SAP transforms it into a gel, effectively locking it away to prevent leaks. Surrounding this core is a series of layers designed to wick moisture away from the skin, keeping the surface dry and comfortable. The top layer, often made of a soft, breathable fabric, ensures that the skin stays dry, while a waterproof backing layer prevents any liquid from seeping through to clothing. These layers work together to manage flow, prevent leaks, and maintain hygiene. What's more, the pad's design allows it to conform to the body's shape, ensuring a discreet and secure fit that moves with you. Despite their simplicity in appearance, menstrual pads are the result of advanced material science and thoughtful design, making them indispensable for women around the world. Traffic lights, the silent guardians of road safety. Traffic lights are more than just red, yellow, and green signals, they are the silent guardians that keep our roads safe and traffic flowing smoothly. At the heart of every traffic light is a controller, a computerized system programmed to change the lights at specific intervals. These controllers are often set based on the time of day and traffic patterns, ensuring that the flow of vehicles is managed efficiently. Some traffic lights are even more advanced, using sensors embedded in the road to detect the presence of vehicles. When a car approaches, these sensors send a signal to the controller, which then adjusts the timing of the lights to minimize wait times and reduce congestion. This smart system ensures that traffic moves as smoothly as possible, even during peak hours. In some cities, traffic lights are part of a larger network, all communicating with each other to optimize the flow of vehicles across multiple intersections. This technology helps to prevent gridlock and accidents, making our commute safer and more efficient. While we often take them for granted, traffic lights play a crucial role in the rhythm of urban life, quietly managing the complex dance of cars, pedestrians, and cyclists on our streets. Thermal printers, the heat behind instant printing. Thermal printers are the unsung heroes of the printing world, often found in places where speed and efficiency are paramount, such as in supermarkets, ATMs, and ticket booths. Unlike traditional printers that rely on ink or toner, thermal printers use heat to create images on special thermosensitive paper. The process begins with the thermal print head, which contains a series of tiny heating elements. As the paper passes under the print head, these elements heat up in specific patterns, causing the coating on the paper to turn black and create the desired image or text. This method is incredibly fast, producing prints almost instantly without the need for drying time. The simplicity of the design also means fewer moving parts, making thermal printers highly reliable and low maintenance. However, the prints produced by thermal printers are typically black and white, and the paper can be sensitive to heat, leading to potential fading over time. Despite these limitations, thermal printers are valued for their speed, quiet operation, and efficiency, making them indispensable in a wide range of applications. Breathing underwater, how submarines generate oxygen. Living underwater for extended periods poses unique challenges, one of the most critical being the need for a reliable oxygen supply. Submarines, which can stay submerged for weeks or even months, solve this problem through a fascinating process known as electrolysis. Electrolysis uses electricity to split water molecules, H2O, into their constituent elements, hydrogen and oxygen. The oxygen is then collected and distributed throughout the submarine to keep the crew breathing, while the hydrogen, which can be explosive, is carefully managed and usually expelled into the ocean. This process is crucial because submarines are sealed environments where fresh air from the surface cannot enter. To ensure the air remains breathable, submarines also employ carbon dioxide scrubbers, which remove CO2 exhaled by the crew, and humidity controls to maintain comfortable living conditions. The technology behind these systems is both sophisticated and essential, allowing submarines to operate stealthily beneath the waves for extended missions without compromising the health and safety of the crew. Electric guitar pickups, the heartbeat of rock and roll. The electric guitar's iconic sound, the very heartbeat of rock and roll, wouldn't be possible without the humble pickup. Pickups are the devices that capture the vibration of the guitar strings and convert them into electrical signals, which can then be amplified and blasted through speakers. At the core of a pickup is a magnet wrapped with a coil of wire. When a string vibrates, it disturbs the magnetic field around the pickup, inducing an electrical current in the coil. This current mirrors the frequency and amplitude of the string's vibration, essentially translating the physical motion into an electrical signal. The signal is then sent to an amplifier, which boosts it and sends it to the speaker, where it's transformed back into sound, only much louder. Different types of pickups, such as single coil or humbucker, can produce different tones, from the bright, crisp sounds of a Stratocaster to the warm, rich tones of a Les Paul. The pickup is more than just a component, it's the bridge between the musician's creativity and the audience's ears, turning the strum of a string into the electrifying energy of rock music. Microphones, capturing sound, amplifying voices. Microphones are the gateway through which sound enters the digital world, capturing everything from the subtle nuances of a whisper to the thunderous roar of a crowd. At the heart of every microphone is a diaphragm, a thin membrane that vibrates when sound waves hit it. These vibrations are then converted into an electrical signal, which can be amplified, recorded, or broadcast. There are several types of microphones, but one of the most common is the dynamic microphone, which operates on electromagnetic principles. In a dynamic microphone, the diaphragm is attached to a coil of wire that surrounds a magnet. As the diaphragm moves in response to sound waves, the coil moves within the magnetic field, generating an electrical current that mirrors the sound wave. This current is then sent through cables to be amplified or recorded. Other types of microphones, like condenser microphones, use variations of this process to capture sound with different characteristics, making them ideal for studio recording. No matter the type, microphones are indispensable tools in a world where sound is central to communication, entertainment, and art, enabling us to share our voices with the world. Neurons, the brain's lightning-fast messengers. Neurons are the fundamental building blocks of the nervous system, responsible for transmitting signals that govern everything from thought to movement. At their core, neurons communicate through a combination of electrical impulses and chemical signals. The process begins with an electrical impulse known as an action potential, which travels down the neuron's long, thin axon. This impulse is a rapid, wave-like reversal of electrical charge that moves along the axon, much like a domino effect. When the action potential reaches the end of the axon, it triggers the release of neurotransmitters, chemical messengers stored in small vesicles. These neurotransmitters are released into the synapse, the tiny gap between neurons, where they bind to receptors on the neighboring neuron. This binding can either excite or inhibit the neighboring neuron, depending on the type of neurotransmitter involved. If the signal is excitatory and strong enough, it will generate a new action potential in the next neuron, propagating the signal onward. This intricate dance of electricity and chemistry allows neurons to transmit information rapidly and efficiently, enabling the complex processes that define human thought, sensation, and behavior. Robotic exoskeletons, augmenting human strength and mobility. Robotic exoskeletons represent a remarkable fusion of technology and human physiology designed to enhance strength, endurance, and mobility. These wearable devices are essentially external frameworks that support and augment the user's body movements. The exoskeleton is powered by a combination of motors and actuators, which work together to amplify the wearer's movements. For example, when a person wearing an exoskeleton initiates a step, sensors embedded in the device detect the movement and send signals to the actuators, which then provide additional force to assist the leg muscles. This not only reduces the physical strain on the wearer but can also enable people with mobility impairments to walk or stand for longer periods. In more advanced models, the exoskeletons are controlled by neural signals, allowing users to direct the device with their thoughts, creating a seamless integration between human intention and robotic action. Whether used in medical rehabilitation, military applications, or industrial settings, robotic exoskeletons are pushing the boundaries of human capability, offering a glimpse into a future where technology and biology work in harmony. Lie detectors, the science of truth and deception. Lie detectors, or polygraphs, are fascinating devices that tap into the body's physiological responses to detect deception. When a person lies, they often experience stress or anxiety, which can trigger measurable changes in their body's physiological state. A polygraph measures these changes through sensors that monitor various parameters such as heart rate, blood pressure, respiratory rate, and skin conductivity. During a polygraph test, the subject is asked a series of questions while these physiological signals are recorded. The underlying principle is that when a person lies, their autonomic nervous system responds with subtle but detectable changes, like a faster heartbeat or increased sweating, that the polygraph can pick up. The data collected is then analyzed to determine whether there is a significant deviation from the subject's baseline readings when they answer specific questions. While polygraphs are widely known, their accuracy and reliability are still a matter of debate, as some people can control their physiological responses or may experience stress unrelated to lying. Nonetheless, polygraphs remain a popular tool in certain investigative contexts, providing insights into human behavior that are as intriguing as they are controversial. Sundials, the ancient timekeepers. Sundials are one of the oldest methods of telling time, using the position of the sun in the sky to mark the passage of hours. The central element of a sundial is the gnomon, a rod or triangular blade that casts a shadow onto a flat surface marked with hour lines. As the sun moves across the sky from east to west, the shadow cast by the gnomon shifts position, indicating the time of day. The design of a sundial is based on the geographic location where it will be used. The angle of the gnomon must be aligned with the Earth's axis and match the latitude of the location to ensure accurate timekeeping. This simple yet ingenious device operates purely on the principles of celestial mechanics and geometry, requiring no batteries or mechanical parts. Sundials were widely used in ancient times, and even today, they are appreciated for their elegance and as symbols of the passage of time. While modern technology has largely replaced sundials, they remain a fascinating reminder of humanity's early efforts to measure and understand the natural world. Bone conduction headphones, hearing through your bones. Bone conduction headphones offer a unique listening experience by transmitting sound through the bones of the skull rather than through the air to the eardrums. This technology works by placing transducers on the cheekbones or near the ears, which convert sound waves into vibrations. These vibrations travel through the bones of the skull directly to the cochlea, the part of the inner ear responsible for hearing, bypassing the eardrum entirely. This method allows users to hear audio clearly while keeping their ears open to surrounding sounds, making bone conduction headphones ideal for activities like running or cycling where awareness of the environment is crucial. This technology is also beneficial for individuals with hearing impairments, particularly those with middle ear damage, as it provides an alternative pathway for sound to reach the inner ear. While the sound quality of bone conduction headphones may not match that of traditional headphones, their ability to deliver sound in a way that leaves the ear canal open offers both practical and safety advantages that make them an innovative choice for many users. The honey-making process, nature's sweet alchemy. Honey production is one of nature's most fascinating processes, carried out by the tireless efforts of honeybees. The process begins when worker bees collect nectar from flowers, which they store in a special stomach called a honey sac. Once the bees return to the hive, they pass the nectar to other worker bees through a process known as trophallaxis. These bees then deposit the nectar into honeycomb cells, where the transformation into honey begins. The nectar is initially very watery, but the bees use their wings to fan the air around the honeycomb, evaporating much of the water content. As the water evaporates, the nectar thickens and undergoes chemical changes, thanks to enzymes added by the bees that break down complex sugars into simpler ones. This not only enhances the sweetness but also acts as a natural preservative, giving honey its long shelf life. Once the honey has reached the desired consistency, the bees cap the cells with beeswax to store it for future use. This remarkable process not only provides food for the bees but also gives us one of the world's most beloved natural sweeteners. And there you have it, an exciting glimpse into the fascinating world of science and technology, filled with wonders that shape our daily lives. From the precision of robotic exoskeletons to the age-old wisdom of sundials, each of these topics shows just how incredible our world truly is. If you enjoyed these fun facts, make sure to hit that subscribe button to stay updated with more intriguing content. And don't forget to drop a comment below, let us know which of these facts you already knew and which one surprised you the most. I'm always eager to hear your thoughts and continue sharing the wonders of our world here on Let Me Share a Fun Fact. Thanks for watching, and see you next time!